Good evening, students. Sorry for the delay in the class. There is some confusion. Give me 5 more minutes to solve that.
Yes, ma'am.
So again, students, we are very sorry for the inconvenience. Let us start the class now. So we will begin with few questions. I believe you are constantly working on the periodic classification, learning the properties. So can somebody tell me the answer to this question? On moving across a period up to group 17, the size of the elements, whether it increases or decreases or what happens? Are you able to hear me or not?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, good. So what is your reply?
Ma'am, it increases.
Ma'am, the size decreases.
We are talking about the period, right? Imagine pictorially what is happening in a period. You can take up second period or the third period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And if I talk about the third one, it will be beginning with sodium, ending with chlorine.
What will decrease?
This is the reason for putting up this question is that in a period, the size decreases if you remember this, and in a group, it increases if you remember this. Understanding the other properties will become easier. So as I told you that when you move from left to right, the positive charge at the center increases, hence the size decreases. This one is from Mendeleev's periodic table, so that we do not mix up with the modern and Mendeleev periodic table. Quickly tell me the answer of this question. The language is slightly different to make it appear difficult. It is not a difficult question.
Mom, is it option 2?
Option 4.
No, option 2.
2. Many elements have several isotopes. Who's that?
Alumna.
Okay, the answer is correct. See, Mendeleev, for this question, we just have to recall the Mendeleev periodic table is based on that we know atomic masses, and the second part which we consider is the similarity in properties. So noble gases do not form compound, doesn't bother him. More importantly, noble gases were not known at that time. Then many elements have several isotopes. That was one of the defects of the modern periodic table. Then atomic weights of elements are not always the whole number. Again, this was also not an issue, and none of these is obviously not the answer. So here, just for example, I have written that many isotopes like carbon 12, 14, oxygen 16, 17, 18 also. Now this question, just first of all, let me know whether you people know what are the elements which are being placed here. Oxygen, sulfur, selenium, and arsenic. Do you know their position in periodic table or not? This question was asked previously in the board exams as well as some of the competitive exams also. Shweta, do you know the relative position of these elements in modern periodic table?
Ma'am, oxygen, it comes in the second group. Yeah, second group.
It comes in second period, not group.
Yeah, second period. Sorry.
Okay. Then see, again, out of hundreds of questions, this question is picked by me for the simple reason that you must understand the importance of learning periodic table vertically, right? That is in terms of group, S block at least. So we have oxygen, sulfur, selenium. All three are the elements of group, period 2 and group 16. Where do we find arsenic?
Mom, is it the last group, like the last, given the last group?
See, as of now, I'm not interested in getting the correct answer. Dear students, the purpose is to find out whether do you remember the periodic table correctly or not. That is the first agenda from my side. This we have to know. I can show you the answer, but the purpose is not this. if I can draw the periodic table, I will say we have boron followed by carbon, nitrogen, then oxygen, then halogen. Oxygen is followed by sulfur and selenium. Nitrogen is followed by phosphorus and arsenic, right? This particular case is a mix of elements from the group as well as the period. So, why the first option is correct? Between oxygen, sulfur, and selenium, since they belong to, this is group 16, and in a group, the size of atom or the atomic radii increases, right? So that means oxygen, sulfur, selenium. Selenium will be the largest in size, right? Then coming to arsenic, if it is of the previous group, its size will be what? Larger or smaller?
Larger.
Larger. So that means this option is correct. Did you understand the logic behind this question and the purpose of making you understand this? See, in periodic table, I'm again telling you that you will not be getting easier questions. The questions are going to be slightly tricky. Whenever we finish the chapter, maybe this class or the next class, we'll be having a test. So for that, it is important for all of you that you remember the S and P block vertically, right? So I think this question is clear to all of you. Not talking about this one. A very easy question. Who knows what is atomic number 19 is? The name of the element, can anybody tell me?
Or is it potassium?
Yeah, that's correct. So Ria, what's the answer? I'm waiting for your responses, students. See the configuration of this element. 1s2, 2s2, 2p6.
Ma'am, is it 17?
Okay. I think that was an Ritika. So
Yes,
why not?
ma'am.
Yeah, but why not 16? And 8 also. Or we can simply write it as 2, 8, 8, 1. It means this element, even if I don't know it is potassium, I know it has got 1 electron in the valence shell. We understood that elements which belong to the group 1 are going to be highly reactive because they have got 1 electron which they always need to shed off or to give it to somebody. So atomic number 8 is what? 2, 6. It is oxygen. So what it will do, it will react with oxygen. I'm not too sure, you might have been taught either by me or anybody else that where do we store sodium and potassium? They are highly reactive they are stored in oil. Kerosene oil to be precise. They are stored in kerosene oil, and potassium is stored in paraffin wax, right? So that they do not come in contact with atmospheric oxygen. So sodium or potassium react with oxygen to form oxide, right? The formula of oxide will be K2O, because the valency of oxygen is 2 and that of potassium is 1. Talking about 17. 17 we know is atomic number of chlorine, which is 287. So what will happen? It will easily form KCl, right? So that was 8, and we must remember 8 and 16 both belong to the same group. Oxygen is 6, sulfur is 16. So again, it will react with it, right? Is it clear to all of you now?
Yes, ma'am.
The correct answer is all of these. See, again, this question is of periodic table as well as chemical reactivity. I felt it is more appropriate to discuss it here because atomic number is given to you, right? So it will react with all of them. Now, this one we did in the last class. This is another perception of finding the correct relationship between the radii. Or do you remember what we did the last thing in the class? We did the ionic radii of cation and anion. Is anybody having any doubt? So kindly let me know so that I can do that section first. We will recall that and then come back to the question. Shweta, is it the concept of size of cation and anion clear to you or not?
Yes, ma'am, it is.
Okay, so I believe it is clear to all of them, all of you. So just tell me the
Yes,
correct answer. Okay, good. So what is the correct answer? Can you see the entire question or not?
Ma'am, is it option 2?
Option?
2.
I didn't get you. 1, 2, 3 or 4?
Option 2.
2. Okay. Let me wait for the other students. The simple trick was that the size of cation is always smaller than the corresponding neutral atom. So in case of K+, the atomic radii should be smaller than 1.34. So the only logical answer will be 0.72, and since the size of anion is always larger than that of cation, so that will be 1.96. Is it clear to you, Ria? I didn't hear anything from you, Ria. Okay, there seems to be some issue. See, don't expect a straightforward question from this section. You can be given a tricky ones like this, right? I think the answer marked here is incorrect. It has to be the option number 2. Or just think logically. Yeah, I think the option is marked incorrect. K should be smaller, so that should be the answer marked here is incorrect. We will take this question in the next class. Let's move to the next concept, that is of ionization enthalpy or ionization potential. Before that, just tell me whether you have been taught about it in the school or not. One by one, beginning with Ritika.
Ma'am, they have taught this topic, ma'am.
Okay. And what about Shweta?
Ma'am?
This topic is taught to you in the school or not?
Yes, ma'am, it is.
Ananya, you? Now, it seems that it is being taught to you, all of you, in the majority of the class. So let me ask you a question. What is the difference between ionization enthalpy and ionization in energy? Or is it
Ionization energy is like the energy that is required to remove an electron. Ionization activity is when it is at constant pressure.
okay? Anybody else? See, there is a slight difference. We should ideally not be using them as a synonym. Although NCERT prefers to use them, but there is a slight difference in between them. Enthalpy means total energy of the system. How do we get that total energy of that system? We say that, or we can take the example of a balloon or a football. If this is the balloon, which is filled with air, right? Now, in this case, what happens? That the particles of air are moving in all direction. As a result, they are going to have kinetic energy, potential energy, translational energy. All types of energies are there in the balloon because of the movement of particles which are present inside it, right? But now, if you squeeze the balloon, that means if you are applying pressure on the balloon, what will happen? Again, I can say in technical terms, we are doing certain work. Work and energy are interconvertible, right? So that means the total energy of system, that is this balloon, will be the energy, one type of energy, which is because of its particles, and the another will be because of the pressure, right? So enthalpy, if I say, should be always higher than ionization energy. Else, as some of, I don't remember the name, I'm so sorry for that, that pressure has to be constant. This is important so that when we do thermodynamics, we do not have any other confusion, right? Now, the second term is that it always has a positive value, because I'm not going to do it in the much of the details of the first thing because you have already done in the class. But every word of this definition is very important. If you are asked to describe what is ionization potential, it is the minimum amount of energy required to remove an most loosely bonded electron from an isolated gaseous atom. Now, can somebody explain to me the meaning of most loosely bonded? What do we mean to say there by this?
Ma'am, they are loosely bonded, like they're very loosely bonded. They don't have a strong bond.
Agreed. See, I'll correct on that. See, if I say, if I remove the word, remove and most loosely bonded, and write the word valence shell electron. Instead of it, if I write valence shell electron, what happens? If let's take the example of, say, carbon. Carbon has configuration 1s2, 2s2, 2p2. Now, in your opinion, does the 2s and 2p have same energy or the different amount of energies? I hope my question is clear. Any answer, Ritika?
Oh, ma'am, no idea, ma'am.
Okay, let's go back to atomic structure. We did, you must have done it in your schools or some other way, that fourth shell will have 4s, 4p, 4d, and 4f. And I believe I might have told you someday with reference to something, I'm not too sure about it, that this is the fourth orbit. This one is the area of 4s. This one is the area of 4p. Next is the area of 4d. And next will be the area of 4f. Making sense to all of you?
Yes, ma'am.
That means the electron which is present in 4s will be the nearest to nucleus. Therefore, it will have highest attraction. So that means between 2s and 2p electrons, the 2p electron will be at a greater distance and they will be lesser attracted, if I can use that term. And this will be more attracted towards nucleus. So that means you will be spending more energy on taking out electron from the 2s orbital as compared to 2p orbital. 2s orbital, if you have to spend 300 joules for 2p, you will be spending, let's say 200 or 150 joules of energy. Is it correct or not? Do you agree, all of you?
Yes, ma'am.
So that is why the word which is more appropriate is that we must say it is most loosely bonded electron from an isolated gaseous atom. So we'll not be using this term, we'll be using this term, right? Because scientific definitions have to be 100% correct. Now, I think this part, isolated gaseous atom in the ground state. Is it clear to you?
Yes, ma'am.
Isolated gaseous means they are at maximum distance from each other so that electron of one atom is not attracted towards the electron of proton of other atom, right? Its value is always positive. What does that mean? It means that you always have to supply energy. The electron wants to be inside atom, but you want it to come out. So therefore, it will always have a positive value. Energy supplied, that's a thermodynamic convection, that energy supplied is positive and energy given out is negative, right? So that's its importance. Moving on, what are the successive ionization energies? Is this concept clear of successive ionization energies? I1, I2, I3. Can somebody tell me out of I1, I2, and I3, which one will be higher and why?
Ionization, enthalpy 3 will be higher.
Why?
Because the electrons are like far away from the nucleus, so more energy will be required to remove the electron.
Just rethink about what you said. Hold on that thought, Ananya. I'm taking an example of aluminium. Aluminium +1, aluminium 2+, and aluminium 3+. Aluminium gives out one electron to become aluminium 1+. Another electron lost becomes aluminium 2+. Another lost becomes aluminium 3+. If I talk about the proton and electron, can somebody tell me what is the atomic number of aluminium? 13, good. All of them are going to have 13 protons. It will have 13, 12, 11, and 10. It will be 281. It will be 282, and this will be 283. Now, you said that the distance will be more as the electron is lost. How is it possible, Ananya? Or whosoever has answered me this question. If I draw the logical circular wala diagram, I will say it has got only 2 shells. So in fact, it has become closer to nucleus, isn't it? Here we were operating with the 3 shells till this. So I might have missed something. Please correct me if I have understood something incorrect. Yeah, Ananya. Or if somebody else has answered me. See, I will say it in a simpler words that number of protons, which the way which we did for isoelectronic species, right? Which will have more attraction. I'll say in aluminium 2+, the attraction between the central nucleus and the valence shell electron will be the highest. So IE3 will be more. As the positive charge increases, at many times, one of the shells is lost. As you can see in case of aluminium 3+. Once the shell is lost, distance decreases. Hence, the size decreases and ionization enthalpy increases. That reminds me that I forgot to ask you this one question. Nobody reminded me of that. Have you done this question? Ritika, any answers? Have you done this question?
No, ma'am.
Everyone forgot it. Ananya, you have done it or not?
No, ma'am.
Shweta, you?
No, ma'am.
Priya, you also not done it or done it?
Ma'am, but I actually did the first question.
Okay. Okay. See, for that day we said ki, it will take a long time to write such a big configurations. And so therefore I gave it to you in the home form of a homework, right? Let me find the periodic table so that we save some time. And answer it quickly. At the same time, I will give you the general electronic configuration. First of all, answering this part, that where do we find element with atomic number 62 and 87? Believe me, 87, it's my just a simple observation. Many a time teachers ask for atomic number 87, which is of francium. So I think that day we discussed it also. So if you have not noted down, please note it out. And atomic number 62 is samara. So you can write it down and find their positions. Else, it's up to you. You need to do a lot of practice into it. That's what I can say. Here is the general electronic configuration of all the blocks of modern periodic table. I think we discussed it till S block, P block, and D block. That is, S block is NS1 or 2 because it has got two shells. Because it has to fill 2 electrons. Either it can be 1 or 2. For P block, we did it as NS2, NP126. For D block, we said the electron enters into the penultimate d orbital. Is this point clear to all of you? That where is the electron entering? In case of d electrons, d orbital. Yes or no? Okay. Now for talking about the F block configuration, in this case, please notice carefully. It is entering into, the last electron is entering into n-2 orbit rather, right? So that means this, what is the name given to the n-2 orbit? If this is the first, second, third, and fourth orbit, and let's say this is a nucleus, so electron will be entering here, n-2. This one is n, this one is n-1, and this one is n-2. Now this n-, as I told you, n is the valence shell that we know very well. n-1, I told you it is penultimate shell. And n-2 is known as anti-penultimate shell. Please keep it in mind, the names. Again, they are important from the multiple choice question perspective. Now, talking about this question, I believe, have you noted down or understood? Should I move further?
Yes, ma'am.
Okay. How will you approach to this question? I will tell you a simple trick. Write the number of proton and then write the number of electron in each one of them and find which is having more attraction. Then you can come to the answer. Please solve this question now. Ria, quickly tell me what are the number of proton and electron in sodium?
11 protons.
11, and electron number is?
I'm sorry, ma'am, your voice okay.
I'm saying if proton are 10, proton are 11, electron are?
10, ma'am, because it's positive.
Okay, good. Shweta, what about magnesium 2 plus?
Protons will be 12 and electrons will be 10.
Aluminium, so I will just write them quickly. Aluminium is 13 and it is 10. What about chlorine? Proton 17
18.
and electron 18, right? Because it has got a negative charge. Now, what about sulfur? Its atomic number, as I told you, is 16. 2 minus means 18, right? Phosphorus, atomic number 15. It's after nitrogen. It's so therefore, if nitrogen is 7, it will be 15. And this is 18. Now, compare the sizes of these three. Which one will be smallest in size? Can Ritika answer me? Out of this sodium, cation, magnesium, 2 positive
Ma'am, your
elements.
voice kind of breaking, ma'am.
Okay. Is it better now?
Yes, ma'am.
Okay. Can Ritika tell me which will be smallest in size? Sodium plus 1, magnesium 2 plus, or aluminum 3 plus?
Ma'am, sodium.
Anyone who differs from Ritika? Okay, let me explain it to you. That I will be drawing a pictorial diagram for each one of them. We'll say there are plus 10 and there is minus 11. In case of magnesium, we have plus 10 and we have minus 12 here. And then we have plus 10 at the center and they have minus 13 to attract. Simple words, I have 10 chocolates, right? I have to, in the first case, I have to share it with 11 people. That means each one will get a slightly smaller fraction of attraction of chocolate than one. There are 10 chocolates. Now there are 12 takers. Still, the portion will be less. And if you have to share it with the 13 people, then share will be still smaller, right? From this example, can you conclude where the attractive forces will be maximum between aluminum 3 plus, magnesium 2 plus, and sodium plus 1? If that is more complicated, let's do this, solve this one first. There are 13, 13, 13, 12, 13, 11, 13, 10. Now, if I ask you between aluminum plus 1, plus 2, and plus 3 is smallest in size, is it obvious that aluminum 3 plus or not? I'm not hearing anything from you. Is my voice clear to all of you now?
Yes.
Yes,
ma'am.
ma'am.
How many of you agree that this will be the smallest one? And so this will be the largest one. Agreed or not?
Yes. Madam.
Okay, because 10 people, see, I again take the same example. 10 people have to attract 10 other people to the center. In this case, 10 people have to attract 13 people. right? So their share will be less, it will be larger in size. Coming back to the example of this species. So this now is it easier for you to pick up or not? Which one will be smallest or largest in size?
Clothing will be the smallest.
I didn't get you. I'm just talking about the first three only. As of now, we are taking up the cations only. These three. Among these three, which one will be the smallest? I'm giving you 2 minutes. You have to compare the cation separately and anion separately.
And the order will be aluminum, magnesium, and then sodium.
Aluminium is the smallest or largest? Shraddha?
Aluminum is the smallest, magnesium is second, and then sodium.
Is it clear now to everyone?
Yes,
Because
ma'am.
aluminium. Okay. Now moving to the anion section. You can again draw the same same way. हाँ भैया हाँ नहीं हम तो थे तुम दरवाजा घंटी नहीं सुनी होगी चलो आ जाओ अच्छा आ जाओ कुंडी लगी हो तो भी खट तुम बजा दिया करो होते हैं घर ठीक now tell me which one will be the largest. Ria, any idea? Any idea, any answer from your side?
Ma'am, phosphate will be the largest.
Yeah, largest one will be chloride or phosphide.
Phosphide, ma'am.
Correct. Good. So what are these species called as? That phosphorus, all of them has 18 electron each. So they are known as isoelectronic species. Most of the time the questions are asked from these only. They are isoelectronic species. Similarly, these are example of another set of isoelectronic species, right? Now, in the isoelectronic species, you can conclude larger the size on cation, smaller will be the size. That is a generalization. If you wish, you can write down that larger the charge, aluminium 3 plus, we have understood it is the smallest. Larger or the more the charge on cation, smaller will be its size. And the reverse is true for the anions, right? So let's move further. Can anybody tell me whether you are clear about the term effect, this nuclear charge? Or it should be easier that nuclear charge is taken as a charge at the nucleus, right? And there is one thing called as screening effect. How many of you know about it? Screening effect, or we call it as a shielding effect. say, we assume this to be an atom, and each of it is, each shell is filled with a required number of electron. This is the valence shell electron, and these are the inner electrons. Now, these electrons, the inner electron, act as a shield or a screen. They protect the valence shell electron from the forces of attraction, right? So as we go down the group, we say that shielding effect or screen effect increases, right? As you can see here, that number of screens or number of inner shells are increasing. It is another terminology to explain the same concept. Here I have tried to draw lithium, sodium, potassium, and rubidium. As we go, what we are writing here is, as we go down the group, the screens or shells increases. Therefore, there is less attraction and lower ionization potential. That means it is easiest to take out the electron. So in this case, what we say, that ionization potential or ionization enthalpy decreases down the group. If you are taught in the class, you must be knowing it. I'm just trying to introduce two more terms which may be seen or which may be used to explain it. And this is again taken from your book, which is showing like this, right? You can see there is a critical high or low. No, they are always decreasing, but the decrease is not smooth. There can be various reasons which we are not supposed to know that. We just need to know that ionization enthalpy in a group decreases, right? Now, similarly, if we talk about the ionization enthalpy of period, you will see the graph is zigzag. Why this is a zigzag? Can anybody tell me? You can see from lithium to neon, it is increasing. But why it is between, if you see the transition between this element, lithium and boron, beryllium has suddenly having higher ionization enthalpy. What about similarly, nitrogen has higher ionization enthalpy than oxygen. Do you know the reason? Shweta, can you tell me the reason?
Can you repeat the question, please?
See, I'm saying, look at the graph carefully. We understand that ionization energy increases when we move from left to right. It is changing from 520 to 2080. But there are certain peaks which I have marked it with the pink or the red color. Between beryllium and boron, beryllium's value is 899, which is greater than boron's value, which is 801. Similarly, between nitrogen and oxygen, oxygen is supposed to have more ionization enthalpy, but it is nitrogen which is having more ionization enthalpy. Can you, do you understand the question?
No, it is because beryllium has like a stable electronic configuration than boron. So it requires more energy to remove the first electron.
Agreed. Here is the explanation for these exceptions, that between beryllium and boron, beryllium has got exactly fulfilled orbital 2s2, and whereas it has got 2p1, which is nearly half-filled, or it is not neither half-filled nor fulfilled. So this is more stable. So ionization enthalpy of beryllium is more than boron. And similarly, in case of nitrogen, it is 2p3, exactly half-filled. It is 2p2, which is nearly, rather it is incorrect. Let me correct it. It should be 2p4. Oxygen should be 2p4. So it has got 2p4, therefore it is nearly fulfilled, right? It is less stable and this is more stable, right? Now we will be doing some questions related to these, to this concept. How many of you are familiar with this type of a question? Ritika, have you seen such type of a question or solved such type
No,
of?
ma'am, I haven't seen this type of questions.
Anybody who has seen this type of question, kindly let me know. Else, see, there is a we are done with the theoretical details of financial enthalpy, but you must be enabled enough from my side to solve all sort of a question. So let us solve this question together. Shweta, are you aware of it?
No.
Okay. Let us solve this question. See, the question says a sudden large jump between the ionization values of third and fourth ionization enthalpies of element would be associated with, and the correct answer is marked as the C part, right? Now we need to understand it in terms of ionization enthalpies. What is happening to the, why there is a sudden jump? Sudden jump will be shown only when the inert gas configuration or is stable configuration comes. So if I take this element, which is given in option C, having electronic configuration as 3s2, 3p1. If it loses one electron, so I'll put it as 1 electron minus. What it will be? It will be lost from this. It will become 3s2, 3p0. Then one more electron lost, it will become 2s1. One more electron lost, it will become s0. Now they are saying a sudden large jump between the values of the third and fourth ionization potential will be seen in which element? This is IE, rather this one will be IE1, 2, 3, and 4. Now, in this case, IE3 is stable. That is exactly half-filled configuration is achieved. Therefore, when you move from here, what will happen? It will require, suppose these values were, say this was 300 kilojoules, it was 600, it was, let's say, 900 or even 1000, it will suddenly become 2000. This is what the meaning of the question is. Now, if this point is clear, let us explore the other options. If I take the first option, which has got 2p6, 3s1, I'm talking of option 1 now. 2p6, 3s1. So if you lose 1, it will become 3s0. Then it will be 2p5 and 2p4. So in either of the case, none of them is exact, neither 5 nor 4. They are not exactly half-filled nor exactly full-filled. So there won't be a very high gap between the third and fourth ionization enthalpies. Now, talking about the second option, which has 2p6, 3s2, it will decrease like 3s1, then 2p5, then 2p4. Again, 2p4 is not stable, right? So it is not going to serve the purpose. The fourth option, it has got 3s2, 3p3. First of all, understand that if it gives out 3 electrons, it will be in this case, it is the first ionization enthalpy, which will be very high, because 3p3 itself is highly stable. So we have to rule it out at the first place, that it will be most stable. Its first ionization enthalpy will be very high. Now, is it clear how you are going to approach to these questions? Ananya, are you clear about it?
Yes, madam.
Anybody, Ria, are you clear about it? If that is clear, let's do one more question before we wind up the class. Just recall what is the trend of ionization potential in the period, and then is there any exception? Ananya, have you got the answer? I couldn't hear you. Just be louder, Ananya, please.
1 minute, ma'am.
Okay. Anyone who has got the answer? First of all, tell me, I have shown you the answer. First of all, tell me what are the first 4 elements of the second period. See, the trick in this question was, it was always going to be the highest one. We have not if you ask me what are the elements of this period, they are lithium, beryllium, boron, carbon, oxygen, nitrogen, fluorine, right? So the value for me, if you ask me to pick from this, has to be the highest one. You can count nitrogen as, nitrogen cannot be counted as element number 1, right? It has to be somewhere in between. So if I say this is 1, 2, 3, 4, I can pick these 4. In such cases, always the correct answer is the highest ionization potential, right? Is it clear or not?
Yes. Yes,
Okay.
ma'am.
Okay. Can we do this question today itself or not? Ritika, can we do it? I think
Yes,
you're-
ma'am.
Okay. If all of you agree, we can do 2-3 more questions. Just say yes or no, so that I can, we can be through with this particular topic. And probably we can make up for the some time which we have lost because of certain unavoidable circumstances.
Yes, ma'am, we can solve.
Okay. The element with the highest second ionization enthalpy is, this one is important one. This, if this is not given in the form of a MCQ, you may be asked to put it like that, that the second period element having the highest second ionization enthalpy is.
Is it lithium?
I heard somebody said lithium, but that's not probably the correct answer.
Ma'am, is it helium?
No, we need to solve this question with student. The trick in this question is, what happens? Second ionization energy means you are taking away the second electron, right? Helium has got 2s2. It gives out one electron. This is IE1. It is 2s1, right? Now it is going to give you 2s0. This is IE2. Then if I talk about beryllium, beryllium was having,
I think answer is beryllium.
sorry, this one is helium is 1s2, 1s1, 2s0. For beryllium, we need to write 2s2, giving out one electron to become 2s1, give out one more electron, become 2s0. Lithium has got 1s2, 2s1. So if I get it gets out one electron, it will form 1s2, right? And for IE2, it will become 1s1. For boron, boron is 1s2, 2s2, 2p1. So IE1 will be, after giving out IE1, it will be 1s2, 2s2. Giving out another one, we'll make it as 1s2, 2s1, right? So what can we conclude? Where is the highest amount of energy required? In case of the second, which one is obtaining the stable configuration? You will say all of them. Then think about which shell you are taking out the electron. Now somebody can somebody explain it to me? See, the trick is that we don't have to focus on the first ionization potential. In the second ionization potential, in case of helium and beryllium, both the cases, you are going to get a more stable configuration, right? But we have to neglect them because in the period when we move like this, ionization enthalpy is going to increase. So we have to focus on lithium and boron. They are ruled out because you are doing them in for first and the second shells, right? When we move to lithium, here the change is more. We say, sorry, I wrote it incorrect. It is 2s2, 2s1. Here, the change is supposed to be more, right? So therefore, lithium +1, taking out electron will be difficult. Boron, it will be still easier. In fact, you are destroying the stable configuration. It has completely failed. You are making it a nearly half, exactly half filled. Is it clear to all of you? Or there seems to be some confusion?
No, ma'am, it's clear.
What about you, Ria? Is it clear? Is it clear, Ria? Ria and Shweta both.
Yes, ma'am. Yes, ma'am.
Okay, usually
Yes,
we talk
ma'am.
about the first ionization enthalpy. Here you are asked for the second ionization enthalpy, right? On the basis of first ionization enthalpy, we can always delete the option 1, helium and beryllium. Then we have to choose between lithium and boron, right? Then this question should be the easier one. Here you are, see, this is just a recap of what we have done. You have to put the order with the exception. Second period is not a straight line, right? So quickly, what will be the correct answer? See, the trick is nitrogen has to be always more than oxygen and beryllium has to be more than boron with the exceptions, right? So I'll appreciate in the next class if you people can do more practice on ionization potential questions. Even if it is taught in your school, please do write and do practice the questions. And we will talk about the electron affinity and try to wind up the chapter in the next class, right? So let's call it a day for the class. I'll see you in the next class on Wednesday. Okay.
Yes, ma'am.
Okay. Thank you. Have a good day.
Thank you, ma'am.
Welcome.